All right, you're watching 6-5 Rational Exponents and Radical Equations. Now, some of you might be wondering, why was I showing a Scooby-Doo intro video? So there's a couple reasons to that. One is I love Scooby-Doo. That actually intro was from 1969, I think. That was the first season of Scooby-Doo. Some of you were like, wow, I didn't realize it was that old. Well, that's very accurate. I didn't realize it was that old either until I was looking at it. Second thing is Scooby-Doo, if you guys know, is kind of like a mystery solver and stuff like that. And this particular video, this particular section, there's a lot of mystery in it, and we have to kind of look at why and how we get some mystery and where those answers come from. Luckily, some of this we've already done before, so that's a very good thing, especially when it comes to extraneous solutions. This is like Scooby-Doo. This is what he prides himself in: extra stuff, extraneous solutions. So remember, extraneous solutions is just an extra solution. Basically, it's a solution that just matches or excluded values from numbers that can't be in the problem, can't work, and then you'll get that answer out, and you'll have to cross it out. We'll go through examples on those anyway. That was from 5.4 and 5.5. We first talked about extraneous solutions, so you can go back in your notes and look at those as well in the video. But let's get to it. This section is not going to be that bad. We're going to go through it really, really fast here because it's not a hard section. Okay, so what we're going to do is square roots first. We'll get through those really, really quickly, and then we'll get to some higher order roots and some rational exponents with equations as well. So if I first start, there's a couple things I need to know. The first thing you always need to do is isolate the root. Whatever the root is, it could be third power, fourth power, 158th power, doesn't matter. These are all square roots, like I said, but I want to isolate the root. What does that mean? That means everything in the root is on one side, where everything else is on the other side. Just like a variable, right? I want variables on one side, numbers on the other. But in this case, I want the roots by itself. Now, it's a square root. So what does that mean? That means in order to get rid of a square root, I have to square it. Okay? If it was a third root, then I would cube it. If it was a fourth root, then I would put it to the fourth power. So the first step is to isolate the root. The second step is to raise both sides to the index. And remember, the index is the root. So square root, third root, fourth root, those are all the indexes. So then I just start now solving, right? So the left-hand side, when I square a square root, I get the number inside. And then now 8 times 8, right? 8 squared is 64, plus 8, n equals 72. Now, it says for extraneous. Well, what does that mean? We talk about excluded values and stuff like that, and we could very easily find excluded values if we wanted to, but I don't really need to. Here's an easy way how to make sure our answer works. Well, I'm going to take the number, put it into the equation. So I have 72 minus 8. Well, what is 72 minus 8? I always put it into the original, not after I do all this stuff, into the original. 72 minus 8 is 64. What's the square root of 64? Well, that's 8, then minus the 1. Does that give me 7? Yes, it does. So my answer checks out. We're good to go. That's what we have to do. We have to check these answers. And we'll get to some problems here where you'll understand why we have to check. Number 2, are my roots isolated? Yeah, I have a root on the left and on the right. So I can square. So I get 3r minus 20 equals r. Bring that over. I get 2r equals 20 and r equals 10. Well, let's see if this works. So what do I get? 30 minus 20 is 10. So root of 10 equals, well, the root of 10. They both are equal to each other, right? So r equals 10 is the right answer. Number 3, let's square both sides because I've already isolated the root. Square. This is x squared equals now 12 minus x. You guys thought we were done solving quadratic equations. Phew, when are you guys going to learn? Bring that over. I get x squared plus x minus 12 equals 0. Factor, right? Negative 12, 1, negative 4. Oh, I'm sorry, positive 4, negative 3. That would have been bad. Then what do? I divide by the a, and then I flip. So the answer is negative 4 and positive 3. That's what our answers are. But wait, what? Let's check, because there's going to be an extraneous solution in here. So let me do a little bit of erasing here, and then we'll we'll get working on it. So I have two answers, -4 and 3. So let's do just the 3. If I plug the 3 in, I get 3 equals the square root of 12 minus 3, which is 9. So does the square root of 9 equal 3? Yes, it does. So 3 is an answer. Now let's check the -4. So -4 equals 12 minus -4, square rooted, right? 12 minus -4 is 16. So does the square root of 16 equal -4? Well, no, it doesn't. And the reason why it doesn't is because, remember, inside a square root, I can never get a negative number out. Ever, 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 ever. That's never going to work. So that's why I have to check my answers, because -4 is not an answer. So the only answer you actually get is +3 in this case. Okay, that's why you got to check. Number 4, and it's not always going to be the negative number. Okay, and you can't just say, oh, it's a -4. It's not never going to work. You can have negative numbers as answers. You just have to check your answer. Okay, so let's go. Number 4. Is one side isolated the root? Yes, it is. So I can square 90 minus p equals p squared. Bring it over. P squared plus p minus 90 equals 0. Quadratic, got to solve. -90, 1. 10, -9, divide by a. Flip, -10 and +9. In this case, I'm just going to tell you right now the -10 is not going to work. And it's not just because it's a negative, because I have the square root on the left and it equals a number, which would be -10, and that we know can't happen. But I still got to check the 9 because it could not work either, and that means that I would have no solution, so I got to check. 90 minus 9 is square root of 81. What's the square root of 81? That's 9. Does that equal 9? It does, so 9 is the only answer I have on number 4 there. Okay, let's go to 5 and then 6.
Okay, on 5, I can square both sides right away. These are pretty simple, right? Hopefully you guys get the hang of these. So that's x squared equals 6 minus x. Bring over. X squared plus x minus 6 equals 0. Factor -6, 1, 3, -2. Divide by 1, and then flip -3 and 2. Okay, again, I know the -3 is not going to work because it can't equal a negative, but I got to check for the 2. So 6 minus 2 is 4. Square rooted equals 2, which again equals the 2 down here, so we know that this is the right answer, number 2. So I can start off by squaring both sides on this one because they're both the square root is isolated. So I get n squared equals, I'm just going to bring this over and bring that over to start. So it's n squared minus the 5n minus the 36 equals 0. Then let's factor. I get -36 and -5, -9 and 4, my two numbers. Divide them by the a and then flip, so I get +9 and -4. What do I know? I know that the -4 is not going to work because, again, it has a negative over here, so it can't equal a negative. So let's try the 9 now. 36 plus 5 times 4 is 5 times 9 is 45, right? Add those together, it's 81. Square root the 81, that's 9, and that equals the 9 over there, so we're good to go. 9 is the only answer that we have. Now let's get into some harder ones, because these are a little harder.
Okay, number 7. Well, I need to isolate the root. Well, this is a negative n on this side, so this has to come over, so it's plus an n. And I'm just going to rearrange this as n plus 3. It just looks better that way. So I have what? I have the square root of 4n plus 8 equals n plus 3. Well, again, I need to isolate the root, which I did, and then I need to square both sides or raise it to the index. The index is 2. Now, when I square a square root, I get the number inside, or the numbers, or whatever's inside, equals. Now, n plus 3 squared should be done in a box, or you can foil. That looks like a little window to like my little home. You can see like me like in the window there and everything. Oh, like creeping on me, creepers. Okay, you can either foil, you can do the box, and you get n squared plus 6n plus 9. Now, it's quadratic. What does that mean? I got to bring this over. I got to bring the 4n over. So I get n squared plus 2n plus 1, which can then be factored to 1 and 1, divide by a, and then flip, which gives you a -1. So let's try the -1, because both of these are the same, right? Get -1 and a -1, so I only need one of them. Let's try the -1 in there to see if it works. In the original, remember the original. Okay, I just cleared it up a little bit for you, so now let's plug the -1 in. Well, I have a negative already here, and I'm putting in a -1, so that really makes it a 1. Plus, now what's in the square root? I get -4 plus 8, right? This is 4 times a -1, which is 4, which is -4, and then plus 8, and then equals 3. Let's see if that works. So I get 1 plus -4 plus 8 is 4, square rooted is 2, equals 3. That works. So -1 is our answer, and it is a negative, which in the other problems the negatives didn't work, but in this case the negative does. So just because you get a negative doesn't mean it's not going to work. Okay, it will work on this one. Square both sides of number 8 because they're already isolated for the root. So I get n minus 10 squared, which in this case is actually n squared minus 20n plus 100 equals 30 minus 3n. Let's bring the 30 over. Let's bring the negative 3n over. N squared minus 17n plus 70 equals 0. Factor. I'm just going to do this real quick. I get negative 7 and negative 10. Divide by a and then flip. I get 7 and positive 10. Now let's check to make sure they work. So let's plug the 7 in. Let's get 7. What do I get? I get 7 minus 10, which is negative 3, equals the square root of 30 minus 21, which is negative 3, equals the square root of 9, which is, that doesn't work at all. So we know the 7 cannot work. And that's a positive number, and that can't work. Oh, man. We just learned something new right there. And then I plugged in the 10. 10 minus 10 is 0. And then 30 minus 10 times 3 is 30. So 30 minus 30 is 0. The square root of 0 is 0. So 10 works. That's your only one. 2 more examples we got. These are pretty difficult. So make sure you bear with me for 9 and 10. Okay, 9 and 10. They look weird because I can't just isolate them, right? I have a square root already isolated here, and then I have a square root here with another number attached. Same thing I'm doing 10. These are going to act different. We're going to have to do 2 times the work. And I know you're just loving that. Okay, so please, again, pay attention here. We should be good to go. It's nothing hard. It's just we got to do 2 times the work. 2 times the fun is like I like to think about it. 2 times the fun. So I got to square both sides to start with. Okay, square both sides. On the left-hand side, I can get rid of that root. That's negative 4 minus 2k. On the right-hand side, I can't just say, oh, that's 1 minus negative 1 minus k. I can't do that because I have a binomial here. So what I'm going to do is I'm going to put that into an x. I'm going to put that into a box here, and let's do some multiplication. So there we go there. Now let's multiply in our box here. Oh, I should start as a negative 1 inside. Oof, almost messed up there. Okay, some of you would like to FOIL and distribute. I don't care. It doesn't matter. 1 times 1 is 1. This is now a negative 1 root negative 1 minus k. This is now a negative 1 root negative 1 minus k. And then this one here, negative times negative is positive, but a square root times a square root, which is the exact same thing, gives me what's inside. Okay, negative 1 minus k. I'm really squaring the square root right there. When I combine terms out of that box, I get 1 minus 1 cancels, but I have a negative k minus 2 root negative 1 minus k. I said a lot of k's there. Ha ha ha. Remember, negative 1 cancels negative 2. The root stays the same. And that equals what? That equals negative 4 minus 2k. Now you'll notice I only have one of the roots left. So now I'm going to bring this over, and then I get negative 4 minus k equals negative 2 root negative 1 minus k. Now, let's do what? Let's divide by the negative 2. And then when I divide by that negative 2, I get negative 4 minus k over negative 2 equals the square root of negative 1 minus k. Now, this is isolated, so now let's square it. Let's square it. So what happens? Well, this is a binomial squared, and then this is a negative 2 squared. So the denominator becomes a positive 4. And then your negative 4 minus k, you can probably going to do a box. So do a box here because I want to FOIL it or distribute or box it. So that's 16, that's a 4k, that's a 4k, and that's a k squared. So I get k squared plus what? 8k plus 16 over 4 equals negative 1 minus k. Are you good with me so far? Hopefully we are. Now I want to solve this. So what am I going to do? I'm going to multiply this by 4. So that gives me, I'm going to come way up top here. I got a lot of room here. Gives me a k squared plus 8k plus 16 equals negative 4 minus 4k. Now I'm going to bring that over, k squared plus 12k plus 20 equals 0. Now I can factor. I get 10 and 2. Those are my two side numbers. I have to divide by 1, which is the a, and I got to flip them, negative 10 and negative 2. So these are 2 answers that I arrive at. Now let's see if they work. Now I'm going to erase a lot of this work, so hopefully you have it down. Now you can't just take it for granted that these 2 numbers are going to work or they're not going to work. Okay, you have to try them. don't just think, well, this is a long problem, and it wouldn't give me no solution, so I'm just going to guess here and circle the other one. Well, no, it's not going to work like that. Okay, you got to just kind of pick one to start with, and let's keep going. So I got the square root of -4, and negative 10 times -2 is positive 20, equals 1 minus square root of -1, and then negative minus a negative means it's a plus 10. So this is what? This is going to be 16, and the square root of 16 is what? 4, right? Equals 1 minus the square root. -1 plus 10 is 9. Okay, 1 minus 9, which is, or square root of 9, which is 3. 1 minus 3 is -2. That doesn't work, so -10 doesn't work. Let's try the -2, see if that'll work. I don't know. Let's find out. Square root of -4 minus 2 times a -2, which is really a plus 4, okay, equals what? Equals 1 minus the square root of -1, and then it's really what? Plus 2, because a negative and a negative make a positive. So this is 0. Square root of 0 is 0, equals 1 minus, and then square root of -1 plus 2, which is 1. Square root of 1 is 1, which makes 0. Those work. So the -2 is the only one. That's it. So this is where you're getting that like Scooby-Dooby-Doo stuff when those Scooby snacks are coming out, because we're getting some shady answers. We got these in the mystery van. If you guys remember watching Scooby-Doo, or you keep watching it now, I don't know what you guys do in your free time. Hopefully do some math, but I don't know if that's right. But we got the mystery van, okay? And all those creepy looking dudes, even they're on Scooby-Doo's team, they're just kind of creepy looking. All right, let's get in number 10 here. Again, I'm going to do the same thing. I'm going to square both sides to start with. Hopefully this one's not as long of a problem, but it might be. I don't know. So 2r plus 1 equals, now I got to do a box on that one. A box, a box, a box, a box. So I get 1 minus square root of 5r minus 4. 1 and then minus the square root of 5r minus 4. So that's a 1. This is a negative root 5r minus 4, negative root 5r minus 4. And then this is going to be a positive 5r minus 4. Now, we could have done that a lot quicker. I could have shown you some strategies with that. I'm not going to do that right now. Either distribute, foil, or you can box it. Okay, so let's combine like terms. So that's 5r, and then it's minus 3, because this 1 and that -4 cancel, or not cancel, but combine, right? And then it's minus 2 root 5r minus 4 equals what? Equals 2r plus 1. So let's bring this over. Let's bring that over. So I get negative 3r plus 4 equals negative 2 root 5r minus 4. So what do I got to do? I got to divide by that -2, divide by that -2. Let's square both sides. Now, some of you are like, well, I could square this side and I'd still get what I get. Well, you know what? That might be right, but I'm just doing it this way. I don't want you guys to screw up, and I don't want to screw it myself, so that's what I'm doing this here for. Okay, and then when I do that, that's cancel, so then I square this here. Now, when I square this on my denominator, I get 4. Then I get what up top? I get negative 3r plus 4. Again, I'm going to make my little box. Again, with me creeping in the window. Help me! Help me! So I get negative 3r plus 4. That's a 9r squared. This is a negative 12r, negative 12r, and then a 16. So what do I get out? I get 9r squared minus 24r plus 16 equals, now when I square root, I get the number inside. Distribute here with that 4 multiplied through. I'm going to come back up on the top left here. Kind of a lot of work. I'm just trying to show you guys, hopefully, some quick ways to do this, but I'm sorry it's taking so long. The next section is going to be a little bit faster, hopefully. I don't know. Probably not, though. You know me. I like to talk. Bring that. Bring that. I get 9r squared minus 44r plus 32 equals 0. So now what? Well, I got a factor, right? So 9 times 32 is 270 and 18, so 288. Negative 44. Let's find out two numbers. All right, my two numbers, we get negative 36 and negative 8. Oh, it took me a little while to figure that out, and I got to divide by the a value, which is 9. So that gives me negative 4, but I got to flip it, or it says positive 4. This gives me negative 8 ninths, which I got to flip, becomes a positive 8 ninths. So now let's plug those back into the original equation and let's figure it out. Let's plug the 4 back in first. So 4, that makes it 8, plus 1 is 9. So the square root of 9 is 3, equals 1 minus 20 minus 4 is 16. Square root of 16 is 4. Oh, sorry, it's just 4. So that's a negative 3. That does not equal that. So we know that 4 cannot be right. Let's try the 8/9. So I get square root of, and then 2 times 8/9 is 16 over 9 plus 1, which is, oh man, 25 over 9, okay? 16 over 9 plus 1 is that, and I square root that, and that gives me 5 over 3, okay? So that's what the left-hand side is. This is the left. So if the right-hand side equals this, then we are good to go. Let's try. I get 1 minus, and then the square root of all that good stuff. 5r times 8 over 9, which is 40 over 9. 40 over 9. And then minus 4, well, on your calculator over that is going to be, oh man, 36 over 9, so that's 4 over 9. And then let's square root that. That's going to be 2 over 3. Sorry, I don't need square root anymore. Square rooted is 2 over 3. 1 minus 2 over 3 doesn't look like it's going to work. That's 1/3. I don't think that is correct, is it not? No, it doesn't look like it's good. So therefore, we don't get an answer. Okay, both of these don't work. So in this case, we have a no solution. Hopefully I did that problem right. If I didn't, I'm going to be mad. What I want you guys to do is try the next 2 problems there, numbers 1 and 2, very similar to what we just did up there, and then hit play when you guys get done. Okay, we're going to kind of go through these pretty fast so we can kind of get done here. So this is squared, so p squared equals negative 1 minus 2p. P squared plus 2p plus 1 equals 0. So when I factor, I get 1 and 1, which is the divided, and then flip, so I get negative 1 is the only answer. And that can't work. Okay, that cannot work at all. Hopefully you realize that. So that means this would be a no solution. Okay, there's never going to be a number that will make that true. Hopefully I did the work right there as well. This one here, I got to square both sides. Square both sides. I'm just going to kind of skip some steps. So I'm going to skip me doing the work, but I'll show the work here. Okay, I'm just not going to kind of talk about it as much. Okay, so I didn't finish the whole problem, but I'll finish it afterwards. But what I did was I took this left-hand side here and I put it into a box. When I multiplied through, and I got 8 plus 1 is 9 minus 2b. Plus 1 of these is each 1, so 2 of the square roots there of 8 minus 2b equals, when I squared the right-hand side, I just get the number inside, so that just became over here. Then what I did was I moved the 9 over, and I moved the 2b over, okay? And then, so I had 2 square rooted 8 minus 2b equals negative 12 minus 5b, divided both sides by 2. I squared both sides, and now I'm going to kind of skip ahead a little bit. Okay, so I squared both sides. On the left, I just got that, right? On my square root, I get that. On the right, I squared the numerator in the box over here. My denominator was 2 squared, which is 4. Then I distributed, basically, I multiplied, or I cross multiplied. I get 32 minus 8b. On the right, I still had 25b squared plus 120b plus 144. I got that from my box. Then I brought the 32 over, brought the negative 8b over, and I got 25b squared plus 128b plus 112. All right, now I'm going to make an x with that. Somewhere in the left-hand side vicinity over here, I'm going to erase some things, and then we'll find our answers. Okay, skip ahead a little bit. I put it into my x, so 25 times 112 is on top, 2800. Bottom is 128. Actually, the numbers weren't as hard as what you guys may have thought, just because they were big doesn't mean they were hard. 28 and 100 were my side numbers, divided by my a, got 4, divided by my a, got 28 25ths. Then I had to flip them, so I got negative 28 25ths and a negative 4. So those are my 2 answers that we are going to try and see if we can get a right answer. Okay, so you can tell I plugged in the negative 28 25ths, and we went through our work here. I used most of my calculator to do all this multiplication and adding and all that stuff to find square roots. So it doesn't actually work. negative 28/25 is not a solution, because once I boil it down, I get 21/5 on the left-hand side, and I get 11/5 on the right-hand side. So therefore, they do not equal each other, so we know negative 28/25 is not right. So then let's check negative 4. Okay, so let's plug in the negative 4. When I do that, I get 8 plus 8 on the inside, which is 16, which is 4 when I square rooted it, plus the 1 still on the outside, so I get 5 on the left. On the right, negative 3 plus 28 is 25. When I square root that, I get 5. So this does work, so that means negative 4 is our lone solution for the second problem there on the U-try. That was kind of a difficult one. That's as hard as they're going to get for those square roots. So let's get down to some higher order roots down in the next page. Okay, you can tell on 11, 12, 13, and 14 that we have some higher order roots. We have third roots, sixth roots, and some fifth roots. Again, the same rules apply. These are going to be a little easier because we're not going to be doing like polynomials, like quadratics and stuff like that. We're just going to be straight up solving a linear equation, so these will be pretty easy. The hardest ones here are the square roots, even though they don't have the highest powers or the highest roots. It kind of doesn't make any sense, but it is what it is. So first things first, again, I'm the realist. I got to isolate for the root, right? So negative 4 divided by negative 4 goes away. I get the sixth root of r minus 23 equals, and this is going to be a 2. Same thing I did up top. I have to raise each side to the index. So the index is a 6. That's the only way I can get stuff to disappear. So that's r minus 23 equals 2 to the 6th power is 64. Let's solve it. Put it on the hook. My DJ revolves it. So I get, 87? That is your only answer. Now let's make sure it works. 87 minus 23 is 64. And the sixth root of 64, remember from the last section, it's really 64 to the 1/6 power. You can type that in your calculator. That gives you 2. Times the negative 4 that's out front equals a negative 8. So the negative... all that stuff works, so 87 is our only answer. Number 12, we got to divide, get rid of it. Third root of k equals 4. Third root, again, I got to raise it to the third power, so k equals, and then what is that? That's a 64, right? 4 to the third power, 64. Let's plug it in. And real quick, I'm not going to do the time to do that, but it is going to work, okay? So it does work for that one there. All right, let's go to 13.
Okay, this is already isolated, so now let's take it to the 5th power. So I get 2x plus 28 equals, this is 32. Bring it over. 2x equals 4, x equals 2. Now let's make sure it works. 2 times 2 is 4, 32, 5th root of 32 is 2, which is good. So that works. 17, bring that over. I got to isolate. That's 2 equals the 6th root of x. 6 power on both sides. That's 64 equals x. If I plug it in, I get, it does work. Okay, it does work. That's it. Now, this is where it gets a little interesting. As you can tell, we don't have now roots. We now have powers with rational exponents. I know we love fractions, but we're going to hopefully know how to do these. So let's get to them. Let's get 15.
Okay, the good thing about when you have rational exponents, not roots, when we have exponents in our question, is we don't have to check to see if answers are extraneous. Okay, we don't have to check. I'm not going to check, and you don't have to either. Whatever answers you get will be the answers. Now, there's one little thing. Well, it's not really little. It's kind of a big problem that we'll get to when we'll get to 16, and then 20 will also have it as well. Okay, and we'll get to that. So let's first know how to do this. The first thing we got to do, isolate the exponents. So this right here has the 3/4 on it. So that means I'm going to move that over. So I get b to the 3/4 equals, and then this goes over, which is 8. Second step is we're going to raise both sides to the inverse fraction. What does inverse mean? Hopefully you remember from inverses. So we're going to raise both sides to the inverse, which is basically the inverse is the flipped fraction. Okay, so 3/4 flipped is 4/3. The inverse is basically the reciprocal. You can think of it as the reciprocal. So what happens is when I do that, this just goes away and I'm left with a b. It just drops it like it's hot down. And then I go on my calculator and I say 8 caret, open parentheses, 4 divide by 3, close. And you should get 16. And that is your answer right there. That's it. Can't do anything with it. That's how we do it. Number 16, I don't even have to check. I can just stay right there. Man, I don't even have to check. This is so easy. Let's go to 16 here. Okay, number 16, this is kind of the weird one. I usually always have a hard time spelling weird, but I spelled it right there. Sometimes I spell it like this. and I look at it and I'm like, wired? That doesn't make any sense. It's like the necessary or some other words like aluminum or cinnamon. Okay, so here's what happens. Again, I can't do anything with this side because all of that is ingrained in the parentheses because the 2/5 is raised to all of that. So what happens is I'm going to raise it to the 5/2, both sides. So that's the same first step. Here's where it changes. On the left-hand side, it stays the same as 7 minus m. But on the right-hand side, if you plug this in your calculator, 4 caret, open parentheses, 5 divided by 2, close, you'll get 32. And this is where it's different. When you raise both sides, okay, after you flip the fraction, when you raise it, if your denominator is even, you get a positive and a negative number when you do that. So this is 32, but really it's a plus and a minus 32. Now the reason you might be asking, well, why does this make sense? Well, because you're introducing an even root. That's what this denominator, remember from last section, the denominator represents the index of your root. And because it's an even root, you can get 2 answers when you solve this. Now, what happens is I take the left-hand side and I get this, okay? And then I split it. 7 minus m equals positive 32. 7 minus m equals negative 32. And I solve them both ways. So minus 7, negative m equals negative 39. Change, m equals positive 39. This one here, minus 7, negative m equals 25. Change, so m equals negative 25. And those are my 2 answers for that problem. Again, you don't have to check them. If you did check them, depending upon which way you wrote it in your calculator, it might say like dimension error or syntax error or just no solution or whatever. But these are your 2 answers. Your calculator will only calculate certain ways, and you would have to do them a little bit differently. If you want help, let me know in class. But for the most part, as long as you know that when the denominator is even, when you flip, you'll get 2 solutions. And we'll get help on number 20 as well. That'll be another one that we'll get 2 answers as well. Let's go to 17. Again, this is already isolated, so let's put it to the third power, So 3k plus 108 equals what? Equals 27. Bring that over. 3k equals negative 81. That looks good. K equals, and I divide right, negative 27. That is our answer there. This is already here, so let's raise it to the 4/3. 4/3, my denominator is not even, so I will not get 2 answers. I only get 1. X minus 13 equals 27 to the 4/3 is 81. Add 13, so that's 94 equals X right there. That's it. Number 19. This one's a little crazy. So I want to isolate for the exponent. So I got to bring the 1 over first. So that's negative 486. Then I got to divide by that negative 2. So that gives me 243 equals 1 minus 4a, because all of that is in the index or in the exponent part, right? It's being raised to that power. Let's flip it. So on the left-hand side, you can do that on your calculator as what? 243 caret open 4 divided by 5, and you should get 81 if I did my math right, equals 1 minus 4a. Bring that over. That's 80 equals negative 4a. So a equals negative 20. There's your answer for that one. Number 20 here. Again, I got to bring the 10 over first. So I get 4 minus 2m raised to the 6/5 power equals 64. Now let's raise it to its reciprocal, 5/6. 5/6. Okay, now I'm introducing an even root. Okay, this is even root. That's 6. So because that is an even root, I get 2 answers. If I do this on a calculator, 64 caret 5 divided by 6, I'll get 32, but it's plus and a minus 32. And on the left-hand side, I get 4 minus 2m. Now I have 2 equations. 4 minus 2m equals 32. 4 minus 2m equals negative 32. This is really where that Scooby-Doo thing came from, right? Again, another instance where it appears. It's just a number that just magically appears out of thin air. We've got to try to find out where it comes from. And that's why we need to enlist the Scooby-Doo team to help us find these answers. So minus 4, we get negative 2m equals 28, m equals negative 14. That's one of our answers right there. And then in our second equation, I got a minus 4 again, minus 4 as well, minus 4. My pen's not working over here. There we go. Negative 2m equals negative 36, m equals 18 when I divide by negative 2. There we go. Those are our two answers. Your two answers, one of them could be positive, say 15, and the other one could be a negative 15. It all depends on what the questions are. Okay, what I want you guys to do is try the next 4 problems, I believe, on the You Try, and then hit play, and then that should conclude this section here. I know it's a little long video, but I am sorry. So let's try the next 4 and be done. Okay, number 3 here. I got to bring the 6 over first, so I got to add the 6, and then I'm really dividing by that negative 2, right? So negative 12 plus 6 is negative 6. Divided by negative 2 is equal to 3. Equals equals the third root of r. So raise it to the third power. So I get r equals, 27. Does that work? That's 3, negative 6, negative 6. Yeah, it does work. That does work. Make sure you check your answers for 3 and 4. You do not need to check them on 5 and 6. Number 4, I got to raise everything to the 4th power. I've already isolated it, so I don't need to worry about it. 21 minus 3k equals 12. So 21 minus 3k equals, and then 3 to the 4th power is 81. So bring that over. I get negative 3k equals 60. K equals negative 20 is our answer. Let's make sure it works. I get negative 20 times 3 is 60, 81, 3. Yeah, we are good to go. This is our answer, negative 20. Number 5, I got to add the 2, so that's 1024 equals 64 to the 5/3 power, 64p. I'm sorry, I almost forgot that. Now I got to raise it to the reciprocal, so I get 3/5. 3/5. 1024 to the 3/5 is 64 equals 64p. Divide, I get p equals 1. Well, that was pretty simple. All that was anticlimactic right there. Number 6, I got to get rid of the 10 first, so that becomes a negative 36. Divide by the negative 4 becomes a positive 9 equals x minus 8 to the 2/3. Now I got to flip it, so it's 3/2. 3/2. But again, 9 to the 3/2 is going to be 27, but it's a plus or minus 27 because you introduce an even root. The denominator is even, equals x minus 8. So you get 27 equals x minus 8, add 8, so x equals 35. And then 27 negative equals x minus 8, add 8, and I get negative 19 is equal to x. You don't even have to check. That's the beauty about this part of the math. Yeah. All right, you don't even have to check. Those are your two answers, 35, negative 19. Okay, if you have any questions, please ask in class, but that will conclude your 6.5 lesson, which is kind of long, but it's really easy. I know there's a lot of problems that we did, but it's pretty simple. So that's all you need. All right, my tagline, it's coming up. Oh, wait, it's right here, right here. All right, take notes, do work, and be successful.